notes for chapter 4, minerals. Um, these notes are notes that I've used in the past. I think they're way better than what comes with the book. So this is more of a whole chapter overview than just that one section of notes 4.2. Okay. All right. The chapter's minerals. All matter. The first part, matter. Elements in the periodic table. Elements are the basic building blocks of minerals. Over 100 elements are known. About 114 or so are known at this point. Okay, so elements build minerals. Minerals then in turn build rocks. Atoms are the smallest particle of matter. You should know that. They have the characteristics of the element. An atom of gold, an atom of hydrogen, an atom of silicon. They all have the properties of that matter, the characteristics of that element. The nucleus is the center part of the atom. You should know that also. And it contains protons and neutrons. Protons are positive. Neutrons have no charge at all. Then we have energy levels. These energy levels, or shells, and I usually call them shells. So that might sound familiar if you've had me in class before. They surround the nucleus. They're orbiting the nucleus, and these electrons are negatively charged particles. The atomic number is the number of protons in the nucleus of an atom. Here we go. Here's the nucleus. Positive protons, neutral neutrons, and then cruising around, forming these shells. And that's why I call it shells. They look more like an egg shell than they do anything else. Okay, these are the electrons cruising around. Protons, neutrons, electronic clouds. Here's the first shell, second shell, third shell. Remember, an isotope of an element have the same number of protons but varying number of neutrons. Isotopes also have different mass numbers. The sum of the neutrons plus the protons is the mass number. So that isotopes have a different mass number. For example, oxygen or carbon-12 and carbon-14. Carbon-14 has 2 extra neutrons. They always have 6 protons, but then it has two extra neutrons. Therefore, carbon-14, 2 extra neutrons. Carbon-12, 6 neutrons. Many isotopes are radioactive and emit energy and particles. And the mass number is the number of neutrons and protons in the nucleus of an atom. Remember, atoms bond because they want 8 electrons in that outer shell. When an atom's outermost energy level does not contain the maximum number of electrons, the atom is likely to form a chemical bond with 1 or more atoms. A compound consists of 2 or more elements that are chemically combined in specific proportions. Remember, a compound is a fixed chemical formula. And then an ion is an atom that gains or loses electrons. So as far as ions are concerned, when they form bonds, it's a magnetic charge. Compounds are formed when they share electrons. Types of chemical bonds. Ionic bonds form between positive and negative ions. Covalent bonds form when atoms share electrons, and then metallic bonds form when metal ions share electrons. 1.2, what is that mineral? A mineral has to be naturally occurring. It is a solid substance. It has an orderly crystalline structure, definite chemical composition, and generally considered inorganic. That means it was never living. How do they form? They crystallize from magma, precipitations or precipitates, pressure and temperature, and hydrothermal solutions. And here's some minerals. Minerals formed as a result of crystallization of magma. Remember that the longer the magma cools, the larger the crystals. There are mineral groups. They can be classified based on their composition. Silicones or silicates. Silicones and oxygen combine a structure called silicon-oxygen tetrahedrons. The silicon-oxygen tetrahedron provides the framework of every silicate mineral. And here it is. Here's the silicon, and the oxygen. This is a tetrahedron, a silicon oxygen tetrahedron. Now, when I get this single tetrahedron, it looks like this right here. But they form chains, okay? Remember, I was telling you silicone, like carbon, forms chains, single chains, double chains, sheets, and three-dimensional networks. These give the individual minerals different properties, whether it is a single tetrahedron or a single chain, double chain, sheets, so on and so forth, okay? There are other mineral groups. They're carbonates, minerals that contain the element carbon and oxygen and one or more other metallic elements. There are oxides, minerals that contain oxygen and one or more other element, which are usually metals. So oxides are usually carbon dioxide, aluminum oxide. Okay. There are sulfates and sulfides, minerals that contain sulfur. There are halides, minerals that contain hydrogen ion plus one or more other elements. Why do I keep wanting to say elements? Halides, okay? These are usually called salts. Native elements, minerals that exist in relatively pure form. Gold, silver, platinum, all right? Stuff like that are found in their pure form. Here's some sulfides, pyrite. I believe this is galena. Copper, native copper. This is another one of those that's found in its native form. Properties of minerals, color. Small amounts of different elements can give the same mineral different colors. What we mean by different colors is if it has iron in it, it's usually orange or reddish color. Sulfur is going to be a yellow color, okay? Streak is the color of a mineral in its powdered form. Luster is used to describe how light is reflected from the surface of a material. This has a metallic luster. Crystal form is the visible expression of a mineral's internal arrangement of atoms. Crystal form is the visible expression of a mineral's internal arrangement of atoms. So you can see these different types of crystals, big blocky crystals, thin, smaller crystals where these are big and blocky. Hardness is a measure of the resistance of a mineral to being scratched. Mohs hardness scale consists of 10 minerals arranged from 10, the hardest, to 1, the softest. Remember, tall girls or guys can flirt, and 4th, quaint things can do. And here it is: talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. And here we have this chart on our homework today. Cleavage is the tendency of a mineral to cleave or break along a flat, even surface. And here is some, I'm going to say it's not biotite, but well, it could be biotite. Notice these sheets, how you can break off this cleaves and sheets. Now, if I go back up here real quick, sheets, it is a silicon oxygen sheet. The dimension here, the 3-dimension, is a sheet. And that's why you can pull out biotite or micro like this on nice, smooth breakage points. Fracture, minerals that do not show cleavage when broken are said to fracture. Fracture is uneven breakage of a mineral, and here is fracture. Notice there are no square pieces, no angles involved. It's just completely and totally random. Density is a property of all matter. That is the ratio of an object's mass to its volume. Distinctive properties of minerals. Some minerals can be recognized by other distinctive properties. They can be identified by density, but also is it magnetic? Does it fluoresce? Okay, these are different types of other properties. I hope this helps.